Now let's look at the second section of chapter 9, and this is the transformation. And for the transformation, there are 4 types of transformation. They are translation, refraction, rotation, and also the last one is the enlargement or reduction. And for these 4 types, so I just want to skip some slides and then look at this slide about to summarize all the 4 types of the transformation. Then we call the new figure formed because after the transformation, a new figure will be formed, and then we call it as image. So image represent the new figure formed after a certain transformation. So for these 4 types of transformation, let's discuss one by one. First of all, the easiest one is about the translation. And translation in Chinese we call it as 平移. 平移 means move the pawn or the figure along a certain direction to a new position. So for this type of the transformation, let's look at some example here. For example, if you have a triangle here, can you see that the original one? We mark the original figure here. And if we say that translate, okay, for the translation, so if we translate this 8 units to the right, then the figure, that means move to the right hand side for 8 units. Then let's count, and then we just always count the vertex, just focus on the vertex. So for example, if you look at this vertex, count for 8 count for 8 units. Okay, so if you look at this, maybe I use another figure. So look at this figure. If you look at this vertex, then count 1, 2, 3, 4, 5, 6, 7, 8. That means up to here, it is 8 units. So we just focus on the vertex and move every vertex. For a triangle, there are 3 vertex. Then move another vertex. For example, this vertex also count for 8 more units to the right hand side, then reach this point. And lastly, this vertex as well. And that's why you can form the new figure here. And for this figure, we call it as the image. And then the properties of the translation is that, and the shape, you can see that the shape of the figure, it is the same as the original one. And how about the size? You also can see that the size are the same. And the direction also the same. So for the meaning of translation, that means only the movement of the figure. Sometimes it may move to the right hand side or left hand side, or move up or down. Okay, and just note at the direction of the movement, and that is the translation. So you can see that there is a point to note that every point on the original figure is moved through the same direction, I mean the same distance in the same direction to form the image. And then for the description of the translation, for example, let's look at this example that if for the translation, the description of the translation may say that a triangle, just give a name for the triangle. For example, triangle ABC is translated to the left. That means first of all, the direction, and also what is the distance. Then you also have to give the information about that, how many units is the movement. Okay. And then let's look at this example 5. You can see that for this example, for the given line, it is marked as XY. The line here called as XY. And then you can see that it is translated 3 units upward. Now it is going up for 3 units. So let's look at the endpoints. Okay, the endpoints X and Y go up for 3 units here. And then for the final position, that means after the movement, after the translation, then the point X will move to here. Then I always mark a cross here, and then I will mark the image of X as X dash. Okay, we call this as the dash， 即係 X 上面一撇啦。Okay, X 上面一撇，我哋通常會用呢一個 symbol. We always use this symbol X dash to represent the final position of X. That means the image of X. And do the same for Y. That look at the endpoint of the line segment. Y move up for 3 units. Then I also count for 1, 2, 3, 3 units. And then finally, Y will be here. Then I just mark the point as Y dash, and then use a ruler to join these 2 points, X dash and Y dash. Then this is the image of XY. So you can see the solution here. You can see that the drawing, the solution of the image of XY after the translation of 3 units upward. This is the answer. Just need to draw the line like this. And then let's look at the next example, also about the translation. But for the translation, for this figure is more complicated than the previous one. And you can see that for this figure, it is quadrilateral. Quadrilaterals, that means the 4-sided polygon, and there are 4 vertex. Okay, and then also for the movement, the translation. For the translation is that there are 2 steps of translation. So you can see that for this 2 steps is that first of all, translate 5 units to the right. So you may do the first step. This is the first step. And then, can you see that? And then 4 units downward. This is the second step of the translation. Then you may just do it one by one. So for A, the vertex A here, first of all, the first step, the first translation, 5 units to the right. So you just need to count 1, 2, 3, 4, 5. That means up to here. Then mark it as A dash. And do the same for B, C, and D. So also start from the point B, count for 5 units, 1, 2, 3, 4, 5. That means up to here. Here is B dash. And next for C, 1, 2, 3, 4, 5. That means up to here. Here is C dash. Lastly for D, 1, 2, 3, 4, 5. That means here. This is D dash. And then use a ruler to join all the 4 vertex. That means the new figure. That means we call the image. But this is not the end of the question, because we only finished the first translation. And you have to do the second step, and then you have to move this figure 4 units downward. So you may, I may use different color of pens. Then I just move this figure 4 units downward. Also do the same, do again for point A, B, C, D, but this is A dash. Then move 4 units, 1, 2, 3, 4. That means up to here. And then I may not call it as A dash. Then I may use the dash dash to mark the new position of A. And B, 1, 2, 3, 4. That means here is B dash dash, and do the same for C 1, 2, 3, 4. That means up to here, C dash dash. And lastly, for D, 1, 2, 3, 4. That means up to here, this D dash dash. So for the translation, it may be 2 steps of the translation. Just do it one by one, and then draw the final figure here. So the blue one is the solution lastly, because we have to do the 2 steps of the translation. And that's why you can look at the solution in the slide. That can you see that we also do in this way. First of all, translate 5 units to the right, and then translate 4 units downward. Then you will get the final answer. That means the drawing like this. And then next, the next transformation is about the refraction. Refraction. So you can see that when we flick a figure along a straight line L, so we may draw a line, and I call this as L. And for this L, I call it as the axis of refraction because refer to this line, then refract the figure here. Refract means like a mirror, okay? The line L like a mirror, and then refract the figure. For example, here you can see the triangle ABC on the left-hand side, and then after the refraction, the triangle ABC will go to the right-hand side. And then you can see that after the refraction, the image formed here should be something like this. And for this kind of transformation, we call it as refraction. And also the dotted line here, because along this line to do the refraction, and then we call it as the axis of refraction. And I think you may have some similar idea about the axis of symmetry that you had learned before. Actually, they are similar, okay? But here we are talking about the refraction, and then for this line, I call it as axis of refraction, like a mirror, okay? To refract the image like this. And then for the properties of the image of after the refraction now, then you can see that the shape of the image, it is the same as original. And the size, you can see that the size did not have any changes. But the direction, you can see that the direction is different, okay? The direction should be opposite to the origin. This is the property about the refraction. And you can see that the corresponding parts are opposite to each other in the refraction. They are opposite. And then some more points you have to note. Actually, it's a very important point to note about the refraction. That the first point, you can see that the original figure and the image combine to form a new figure that has refractional symmetry. Can you see that? So I told you that actually it is similar as the previous section that we had discussed about the symmetry, and it is about the refractional symmetry. And L, we call it as the axis of symmetry, or we call it as the axis of refraction. And then the point B is that the corresponding parts means that, for example, if you look at the vertex A, and then it corresponds to the image of A, that means the A dash. And then you can see that the original figure and the image are equidistant from L. That means, what is the meaning about this equidistance? That means same distance, okay? They have the same distance, about that, equidistance. That means same distance, or you may say that same length, okay? For the meaning of this word, equidistance, that means they have same distance. And for example, if you look at here, the distance between point A and the line L, that means this distance. If I say that this distance is equal to small letter A, and then the distance between the image of A, that means A dash, and the line L. That means this distance also equals to A. That's why they are equidistance. And the same for the other points. That means, for example, for point C, the distance between C and L, I may call it as C, and then this distance also equal to C. Then you can draw the refraction easily by using this property. You know that because the corresponding parts of the original figure and the image are equidistant from L. That means equidistant from the axis of refraction. So this is a very important point you have to note. And then let's look at another example on the next slide. In the drawing about the refraction, so you have to follow the steps like this. For example, if you have a figure, I mean the triangle DEF here, and it is refract about this line L, and the L we call it as the axis of refraction. So you can see that what is your first step? Draw D dash. D dash, that means what is the image of D, which is perpendicular to L. And you just can see that DO, I may call this point as O. That means this distance, okay, we always to count the distance here. Of course, the distance here is 2 units. And then move for further 2 units. Then that is the new position of point D after the refraction. And then I just call this point as D dash. That is the image of D after the refraction. And then do the same for E and F. Step 2 is that. Do the same for E and F. So you can count from point E, draw a line which is perpendicular to L. And then you may meet the point P here. Just to count 1, 2, 3, 4, 5. There are 5 units. Okay, there are 5 units, and that's why. Here, and if you say that here, there are 5 units. Okay, I may mark here 5 units. Then you need to count 5 more units. Then you can mark the point E dash. And the same for F here, 3 units. And here also further 3 units. Then you can mark the point F. Then you can join the lines D dash, E dash, and F dash. That is the image after the refraction here. So if you can get such idea, I think the drawing about refraction is not difficult. And then you can look at the next example. Just use the same idea that you had learned about refraction that. And for this is the quadrilateral ABCD again. And then if you want to draw the image after the refraction about the straight line L, then just try to look at the figure and count how many units between A and the line L. Of course, you should draw a perpendicular line to L, and then you need to count here the distance, which is 3 units. And then you have to further to draw 3 more units. I mean to count 3 more units here. And then you can reach the point, I mean the image of A after the refraction. And then do the same for B, C, and D. Then you need to count what is the distance between point B and the line L. 1, 2, 3, 4, 5. There are 5 units. Then count for more 5 units. 1, 2, 3, 4, 5. That means up to here. And then you can do the same for C and D. I don't want to repeat. I think you can do it. Okay, so this is a very simple idea about how to draw the image after the refraction. And then next, after translation, refraction, next is about the rotation. Rotation, that means need to turn, okay, to turn something, to turn the figure to a certain position. So for the rotation, then we have to rotate a figure about a fixed point. And this point, we will call it as the center of rotation, okay? And then the new figure can be formed, for example, here, a letter H. And if O here is the fixed point, then if we rotate, okay, if we rotate the letter H, and in this direction, okay, of course, you have to mention what is the direction of the rotation. Now you can see that the image is rotated in this direction, and this direction recorded as the clockwise direction. Clockwise direction 即係順時針方向，係嘛？我哋將呢一個圖順時針方向轉。That means we rotate the figure in clockwise direction. And for this angle, you have to mention what is the size of the angle as well. And now I think you can see that that is a right angle. That means rotate 90 degrees in the clockwise direction. Then you can form the new figure here, and that we also call it as the image. And then in the rotation, you can see that the fixed point, we call it as the center of rotation, which is similar to that you had learned in the previous section that about the rotational symmetry. Okay, we also have the fixed point, called it as center of rotation. And then now let's look at some more properties about the rotation. And then for the image after the rotation, you can see that the shape of the image, that is the same. Because for example, if a straight line OA, if it is rotate in this clockwise direction again, finally, this is also a straight line OA. So the shape of the image will not be changed. And next is the size. Size also the same. Okay, because you can count originally the length of OA, that is 1, 2, 3, 4, 4 units, and after the rotation, that means go to the image A here, image of A here, you can count this line segment also equal to 4 units. That means the size will not be changed. But the direction, you can see that of course it is changed because it is rotated. Of course the direction will be changed. So here are points to note about the rotation is that every point on the original figure is rotated. Should be every point should be rotated about the center of rotation through the same angle to form the new image. So here some points to note about to describe the rotation. First of all, we have to know where is the center of rotation. Next, direction. Then we always describe the direction as clockwise or anti-clockwise. I hope that you know what is the direction for clockwise and anti-clockwise. For clockwise, that means rotate in this direction. Okay, and anti-clockwise, that is rotate in this direction. Also, you have to mention what is the size of the angle. That means the angle of rotation. So for example, in the description about the rotation, we may describe it as rotate, first of all, direction, anti-clockwise, about where is the fixed point. The point is point O, and what is the angle of rotation. You have to mention these three, okay, these 3 points to describe the rotation. And then for this, I don't want to describe any more about this rotation. I think you can read it by yourself, But I just want to mention one point about the rotation of 180 degrees. I think you may look at the next slide here. You can see that if the rotation about the fixed point through 180 degrees, if it is rotating for 180 degrees, actually in any direction, I mean clockwise or anti-clockwise, actually they are the same. So if the rotation is for 180 degrees, sometimes we may not mention the direction because actually they are the same. Okay, so I just want to point out this point. And then let's look at some examples in the next slides. First of all, for this, you can see that for part A, for the triangle here, triangle ABC, and then you can see that for the triangle ABC, and then we should rotate the triangle ABC. You can see that first of all, the direction, and then where is the center of rotation, and also the angle of rotation. So now the fixed point is B. So here is the fixed point. You have to rotate the triangle about this fixed point. That means this point will not move. And this point B is also lying on the triangle. That's why B, after the rotation, it will not move. So I think you may first mark the image of point B here. Actually, in the same position as B, because B is the fixed point, because the rotation is about the point B. And next is about part, I mean the point A. Okay, so maybe I try to draw again here. The point B, it will not change. And then let's look at point A. Point A. You can see that because now B is the center of rotation, because B is the fixed point, and then the direction is in anti-clockwise. That means rotate in this direction. This is the anti-clockwise direction. So point A should move in this direction for 90 degrees. So I may consider point A move in this direction. Then in the movement, I always look at the point here. I always look at the point here. For point A, move in this direction. And then I always draw a line between the vertex A and the fixed point B. Then rotate for 90 degrees. And remember, the length of AB should not be changed. That is 1 unit. That's why after the rotation, also 1 unit. So here is the image of A. And do the same for point C. Point C, also try to draw a line. Now I may use different color. Try to draw a line to join point C and the center of rotation. That means CB. And for the length of CB, that is 2 units. And also you have to rotate. Okay, you have to rotate. I may draw again. Sorry for the. Okay. I may draw again for the line here. And then you have to rotate in the anti-clockwise direction for 90 degrees. For this line, move for 90 degrees. Okay, here is 90 degrees. And keep the line segment also equal to 2 units. That means here. So the image of C should be here. And the image of B the same as point B. also the image of A is here because I erased this before, but I mark it again here, and then try to join the vertex, I mean A dash, B dash, and then C dash. Then you will get the image after the rotation for part A, the red part, okay? The red part is the solution for part A. And then for part B, actually do the same, but now the fixed point is changed. The fixed point is O. So I may use the next slide to explain about this. Because for this, now, you know that for part B, O is the fixed point. Then you have to consider the three vertices here, A, B, and C. First of all, let's look at A. Then I may join the line segment A and the fixed point. And for part B, I know that I have to rotate it in the clockwise direction. That means this direction for 90 degrees. And this line segment is 1 unit. And then move here. So I know that after the movement, after the rotation, after the rotation, here should be A dash. And do the same for B. For B, you can see that actually this is 2 units and move in the same direction. Rotate it clockwise. Then 2 units, that means up to here. So you can mark the point B, the image of B here easily. And lastly, for C. For C, how to mark C? Actually, it's very easy because you know that AB originally, the length of AB is 1 unit, and then BC is 2 units. So you know that here should be 2 units because the size of the image should be the same as the original one in the rotation. That's why C should be 2 units away from B. And here should be the image of C. And that's why you can form the image like this. Okay, so for this, you can see that finally the image is formed here. Okay, so remember for the rotation, the length of each line segment should not be changed. They should be the same. Okay, then this is about the rotation. And lastly, about the enlargement and reduction. Enlargement 放大咗 and reduction 縮細咗. Okay, and then how to describe the enlargement or reduction? For example, if here is the original figure, and then I make a bigger one, that is the enlargement. And then if I make a smaller one, that is the reduction. But for the enlargement and reduction, I just want you to learn 2 factors about enlargement and reduction. It's very important for the enlargement and reduction. For example, if you look at this one, originally the figure ABCD is a rectangle here. And then after the enlargement, of course, I hope that you can see that this is the enlargement because the A dash, B dash, C dash, and D dash, this is a larger rectangle than the original one. So it is the enlargement. Then how to find the enlargement factor? Now, sometimes the question may ask you to find the enlargement factor. Then how to find it? I just use the 2 corresponding sign. Okay, any corresponding sign. What is the meaning of the corresponding sign? For example, the line segment AB correspond to A dash, B dash. Then we call these two line segments as a pair of corresponding side. And then we have to divide it. And we always use the image length, okay? I mean the length of the image, that is A dash, B dash, divided by the original length, that is AB. And if we just count from here 2 units and then divided by 1 unit, because here is equal to 2 and here is equal to 1, and that's why the enlargement factor is equal to 2. And can you see that actually you can find 4 pairs of corresponding sides here because it is a 4-sided polygon, because this is a rectangle. So you just need to use any pair. That means you may use this pair or this pair or this pair or this pair. Just use any one. No need to use all of them. Just use any one of the pair. Then you can find the enlargement factor. And in the calculation of the reduction factor, actually, it is the same. Okay? Actually, in calculating the reduction factor, it is the same that also use the corresponding size. And for the reduction factor, you can see that for the reduction, also we use the image length divided by the original one. The image here is 1 and the original one, the length is equal to 2, and that's why the reduction factor here is 1 over 2. And of course, for in the reduction, the image figure should be smaller than the original figure. So in the enlargement or reduction, you have to learn about how to calculate the enlargement factor and the reduction factor. And then there are some points to note about the enlargement and reduction. The shape of the image should be the same, okay? But the size is different because sometimes it may be enlarged or reduced. And the direction is the same as before. Okay, so remember the important thing for the enlargement and the reduction is that we need to know how to calculate the enlargement factor and the reduction factor. And then for the drawing, I think I don't want to discuss about this drawing. I think because this part is easy, I think you can try to have a look about this example of the enlargement and reduction. And I just want you to learn how to calculate the reduction factor. Remember how to calculate it. Should use the length of the image. And if you look at the figure here, BC, the image of BC, that is B dash, C dash, and then divided by the original length, that is BC. In the calculation of the reduction factor, we have to calculate in this way, and then just need to count what is the length of B dash, C dash, and here 1, 2, 3, 3 units, and then divided by originally for BC, that is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. And that's why finally, after simplifications, that is 1 over 3. This is the reduction factor. Remember how to calculate the reduction factor. And it's the same for the enlargement factor. Okay. And lastly, here you will find the summary about the transformation of these 4 types of the transformation. Okay, so for this part, I think after the reading of this PowerPoint and the video, and I think you can finish the worksheet. I mean, that is the exercise 9B worksheet, and you have to do quite a lot of drawing on the worksheet. So I suggest that you can print out the worksheet, or you can do all the exercise, I mean the drawing, on your MacBook, and then take a photo on your MacBook and then upload your exercise in the Google Classroom. Okay.